Okay, today I am going to show you the installation of Kjeldahl infrared digestion unit. The infrared digestion unit will be supplied to you in a dismantled state. The unit has to be assembled by a local executive. The unit comes with a digester, 6 quartz tubes, a stand to hold the 6 quartz tubes and an exhaust manifold. Now, unlike others, we supply quartz tubes. Quartz can withstand sudden heating and sudden cooling. The infrared digestion takes place at around 420 degrees Celsius, which is a very high temperature. In most of the places, the digestion tubes break down. The digestion tubes breaks here. To avoid that, we have started supplying quartz tubes. Quartz tubes can be suddenly heated up to 420 degrees Celsius without the fear of breakage. It can withstand good thermal shock. Okay. Now, before I start the experiment, first we have to take the sample. Now, your sample should be homogeneous. It should not be heterogeneous. What I mean to say is, the sample should be finely ground to powder and it should be free from moisture. To remove the moisture, you can heat it in a oven at around 105 degrees Celsius. Wait for some time. See that there is no moisture content and then weigh the sample. Now, how much amount of quantity should you take as a sample? Now, there is a chart and there is a guide for this. Okay. If the protein content is very high, then you have to take small amount of sample. Say for example, the protein content is more than 30%. You have to take approximately 0.2 to 0.5 gram of sample. But in some cases, if the protein content is very less or if the nitrogen content is very less, then large amount of sample has to be taken, approximately 1.5 to 2 grams. One important thing is, if the sample is homogeneous, if the nitrogen content is evenly distributed, then only you will be able to get the correct results. In certain samples, the material is not homogeneous. So what I request you to do is, try to finely grind it using a mixer and try to make it as fine as possible so that the protein content is evenly distributed. If the sample is heterogeneous, then it is very difficult to find out the nitrogen content and it will not be the same for all the analysis. Okay. Now, I have taken milk powder, okay, and then Horlicks as my sample. Now, before starting the experiment, I have numbered it as 1, 2, 3, 4, 5, 6. Usually, the first one is a blank. What do you mean by a blank digestion? That means you have to take all the items for the digestion except the sample. You don't have to take the sample. Instead of sample, you can take distilled water. So usually distilled water is taken as a blank. Then I have taken the samples. Please number it as 2, 3, 4, 5, 6 so that you will be able to identify it at a later stage during calculation. Okay. Now, I have taken a weighing balance. You have to have a very good weighing balance. The weighing balance should be able to measure 0.1 milligram of accuracy. Weigh approximately 0.2 to 0.5 gram of the sample. Okay. Now, use a butter paper and weigh the sample. Take a spatula. Okay. I shall weigh approximately 0.5 gram of the sample. Take 0.5 gram of the sample in a butter paper and transfer it into the digestion tube. Now, during transferring this sample into the digestion tube, see that the entire sample goes to the bottom of the digestion tube and nothing sticks to the wall. Okay. Transfer the entire sample to the digestion tube carefully. Suppose this is a digestion tube. Here I have already loaded the sample. Then transfer the entire content carefully. That means you have to insert it like this and transfer it and then tap it gently so that the entire sample of 0.5 gram goes into the digestion tube. This is very important because even if there is a variation of 0.1 gram, then it will affect the reading during calculation. Okay. Now take 0.5 gram of sample in all these digestion tubes, quartz tubes. To this we have to add a catalyst mixture. Now for the catalyst mixture, please refer the guide. Usually it will be 5:1 ratio. That means you have to take potassium sulfate and copper sulfate as the catalyst mixture. Approximately 5 grams of potassium sulfate and 1 gram of copper sulfate is taken, or 3.5 grams of potassium sulfate and 0.5 gram of copper sulfate is added. Now I have already added that to these digestion tubes. You can observe it here. In this digestion tube, I have added the sample of 0.5 gram, around 3.5 grams of potassium sulfate and 0.5 gram of copper sulfate. Okay. Now to this you have to add approximately 12 ml of sulfuric acid, which is concentrated 98% sulfuric acid. Now the addition of sulfuric acid also depends upon the sample. Please refer the Kjeldahl guide as to how much amount of sulfuric acid has to be added for each particular sample. Okay, now I have sulfuric acid here concentrated. So I will be adding 12 ml of sulfuric acid using a borosil measuring cylinder. Okay. So I have taken 12 ml of sulfuric acid. I will slowly add to the walls. Through the walls, be very careful, use gloves. Thank you. Now, I have added 12 ml of concentrated sulfuric acid to all the digestion tubes. To the blank also I have added. For the blank, instead of the sample, I have taken distilled water. I have added 12 ml of sulfuric acid even to the blank. Now, you can check. I have added sample, catalyst mixture and sulfuric acid of 12 ml to all the digestion tubes. Now, after this stage, I have to keep the fume exhaust manifold onto this. I will just lift it carefully and then place it in position. Okay. I have lifted the exhaust manifold and placed it in position. Before switching on the unit, I have checked whether it has firmly taken the seat. Okay. So I have checked, everything is okay. Now I shall switch on the digestion unit. Now, most of the digestions happen at around 420 degrees Celsius. So I have set the temperature here at 420 degrees Celsius. Now here we have a digital temperature indicator. At the top you can see the process value and at the bottom you can see the set value. This is the process value and this is the set value. Now This is the heater indicator. That means when it is glowing, the heater is on. Okay. Now I can increase or decrease the temperature by pressing it on the square button and using the up arrow or the down arrow. Okay. If I press the up arrow, the temperature increases. If I press the down arrow, the temperature decreases. Now, there are two set points here. One is the set 1 and another one is the set 2. Now, what is set 1 and what is set 2? I will explain it to you. Set 1 is the temperature at which you want to do the temperature settings. Okay, at set 1 module, you can do the temperature setting of this instrument. At set 2, you can set an alarm. Okay, suppose you want to set the temperature at 420 degrees Celsius and start an alarm at 425 degrees Celsius. What I need to do is, I just go to set 1, set it at 420 degrees Celsius. Okay, this is my set point, and then when I want to set an alarm at 5 degrees Celsius more than the required temperature, then I go to set 2. In set 2, I set the temperature. Okay, now set 2 is the alarm temperature. Now I have set it at 5 degrees above 420. Once again I come back to the basic module and see here, you can see here, this is the process value, this is the set value. That means the process is at 63 degrees Celsius, the set value is at 420 degrees Celsius. If I press this, it goes to the set 2 option where I have set it at 5 degrees Celsius. That means when the temperature reaches 425 degrees Celsius, an alarm will start for you to come and attend to the unit and to ensure that the digestion happens at a uniform temperature of 420 degrees Celsius. The alarm is only a safety precaution. Okay, now I shall go back once again to the set 1 module. Now, it has already achieved around 80 degrees Celsius. The acid is getting heated up and it is started boiling. Now, sulfuric acid boils at 338 degrees Celsius. The boiling point of sulfuric acid is above 338 degrees Celsius. Now, initially when we boil the sample with sulfuric acid, sulfur dioxide fumes are being liberated, which are very pungent. Okay, to remove the fumes, we use a filter pump. Now, how does this filter pump work? Now, this is the filter pump. This goes to the tap. This goes to the suction module, and here water flows. Now, there is something called as a Venturi action. What happens is, when water starts flowing through this filter pump, a suction is created and the vapors are being sucked and the sulfur dioxide vapors get mixed with water and goes to the sink. Okay, so this is very good. I will show you how it works. Now I shall just switch on the filter pump. Okay, now as soon as I switch on the filter pump, water will start flowing and sulfur dioxide vapors will start getting sucked from the acid resistant tube. The sulfur dioxide vapor gets mixed with water, it becomes dilute sulfuric acid and it goes into the sink. Now by this method, as you can see, even when acid is boiling, I am standing next to it and I am not able to see any vapors because all the vapors are going and getting sucked and it is getting mixed, becoming dilute and going to the sink. Okay. Now, I shall just place it in the sink. Now, the flow of water is very important. Do not increase the flow of water to such an extent that all the acid fumes get sucked up and goes into the sink. It has to be optimal. What do you mean by that? That means sulfur dioxide fumes are generated only during the initial stage of boiling. After that, there is no sulfur dioxide. So only during the initial stages, you have to keep the water flow at considerable speed. Afterwards, the water flow should be minimized. Now this can be developed only by experience. Only by doing 2 or 3 experiments you will only understand. Suppose you increase the water rate fully, then all the acid will get sucked out and it will result in incomplete digestion. So only during initial experiment the water flow should be there. As and when the temperature achieves around 300 to 350 degrees Celsius, it has to be slowly turned off so that there is a reflux of sulfuric acid and there is no distillation of sulfuric acid. We do not want sulfuric acid to distill out. It has to boil and it has to be inside the digestion tube itself. So only during the initial experiment it should be in this flow. Okay. Now if you observe it closely here, as you can see, there is already acid fumes which is being developed. This is sulfur dioxide fumes. Okay. Over a period of time it will disappear and the digestion tube will become transparent. You can observe it when the temperature goes beyond 338 degrees Celsius. Now there is rigorous boiling. That means our milk powder, sulfuric acid, catalyst, they are all boiling as the temperature is being raised. Once the temperature clears 330 degrees Celsius, the digestion tube becomes transparent, the sulfur dioxide fumes becomes less. Okay, at that point you can lift this module and check whether the digestion is over. Okay, now we shall continue it. Now I have set the temperature at around 420 degrees Celsius. As I have explained it to you, the top temperature is the process value, the bottom one is the set value. I have set this at 420 degrees Celsius. It has already achieved 340 degrees Celsius within a span of half an hour. Now, one more thing is, you can observe that the quartz tubes have become clear. That means there is no sulfur dioxide fumes here. It has become clear. At this point, please reduce the flow of water. So now you can see the flow of water. I have reduced it. We do not want to increase the flow of water. If you increase the flow of water, all the sulfur dioxide will get absorbed in water and go away. There won't be any sulfuric acid in the digestion vessel. So you have to reduce the flow of water. Okay, I have reduced it and I am keeping it here. One more thing is, you can set this temperature as well as there is you can set this temperature as well as an alarm. That means when it achieves 420 degrees Celsius, you can put an alarm so that when the set temperature is attained, somebody can come and observe it. This can be done only in this set 2 module. So I shall go to set 2 and I have kept the alarm for 422 degrees Celsius. Now I just want to know whether the digestion has happened or not. Okay. So what I will do is, I will just lift it and show it to you and you can observe it whether the digestion has occurred or not. To ensure that the digestion has completed, the liquid has to be transparent. All the 6, the liquid has to be transparent. Now in the blank where we take distilled water, naturally it will be transparent, but that is not the case. It should be transparent in all the 6. Okay. I will just lift it and show it to you. Okay. Have you observed it? The digestion is incomplete. I am going to keep it once again here and continue it. The temperature is just 347 degrees Celsius. That is why there is an incomplete digestion. Once the digestion is complete, all the liquids in all the digestion vessel will become almost bluish green in color. So we shall continue it. Now during digestion, never lift this exhaust, because if you lift this exhaust, then all the sulfur dioxide fumes is going to occupy your laboratory. Never lift this exhaust. Always keep it on the digested tube. Never touch the heating zone. We would have put a label, but I am just telling you, never touch this heating zone. Okay. This is the temperature control module. This is the heating zone. It is completely made up of stainless steel, and there are two infrared heaters. There are two quartz heaters on either side of the digester. Okay. There are one set of heater on that side and one set of heater on the other side. Okay. Now, you can observe here that as the temperature approaches 420 degrees Celsius, the heater is getting switched on and switched off. This is because this has a PID controller. Okay. Now what the controller does is, as now you can see the heater is switched off. After a few seconds the heater will once again switch on. This happens because the heater has sensed that it has almost approached the temperature. Now once this happens, the heater gets switched on and switched off. That means the sensor is passing this information to the heater, and the heater into the controller, and the controller is restricting the flow of current. So now you have seen it is 413 degrees Celsius. So the heater will get switched on, switched off, switched on, switched off until it achieves 420 degrees Celsius, which is the correct temperature. Okay. So suppose you set it at 430 degrees Celsius, it will start from 420, switch on, switch off, switch on, switch off, and achieve 430. Now I have switched it, kept it at 420, so it is started fluctuating until it achieves 420 degrees Celsius. I will once again lift this and let me observe whether the digestion has happened. Okay, now it is almost getting clear. I will once again keep it here. You must have observed it, all the digestion tubes have become fully clear. The haziness is no longer there, and sulfur dioxide fumes are not there here. Okay. So now it has achieved the boiling temperature. There is rigorous boiling happening inside the digester.
Heat up to 500 degrees Celsius. What will happen? Protein will denature or what? It lasts by at point. 420 is
not 420. That is by practice only. For certain food items, there is a protein section to suppose 3%. Then you don't have to set that up to 420. Actually, you are 60 minutes. That's why you have to keep this heat.
no way. That is why I am asking you. So what is this sting and picking?
Now I will just lift it once again and see. It is almost through, but it is not fully over. Okay. During lifting, you have to be very careful. I request you to kindly lift this and keep it down very carefully. It takes approximately 15 to 20 minutes after it achieves 420 degrees Celsius for the digestion sample to become clear. Okay. So once it achieves 420 degrees Celsius, you have to allow it for minimum 20 to 30 minutes for the entire digestion to take place. One more thing is, while transferring the sample to the digestion vessel, see that no sample sticks to the walls of the digestion tube. And after the digestion is over, there should not be any carbonized material in the digested sample. Now what do I mean by that? It means that after digestion, your liquid should be clear. The color of the liquid is not important. The color of the liquid is because of the catalyst used. But after digestion, the liquid should be clear and there should not be any black particles inside the digested tube. If there is any black particles inside the digested tube, it means that the digestion is not fully complete or it is not 100%, and naturally it will give you varying results when you do the distillation. Now, we have taken approximately 12 ml of sulfuric acid. Now, the quantity of sulfuric acid depends upon the protein or the nitrogen content. Usually, higher the nitrogen content, you have to take more amount of sulfuric acid. So, please refer the guide and you yourself decide how much amount of sulfuric acid has to be taken. For approximately 0.5 gram of the sample, 12 ml of sulfuric acid is enough. But once you start increasing the weight of the sample, you have to increase the volume of the sulfuric acid also. Now, suppose instead of taking 12 ml, if you take 20 ml of sulfuric acid, then during the distillation process, instead of adding 40 ml of sodium hydroxide, you might have to add 60 or 80 ml of sodium hydroxide solution. So I hope you have understood this concept. Suppose you increase the volume of sulfuric acid, then you have to increase the volume of sodium hydroxide during the distillation process also. Okay, now it is almost 1 hour 20 minutes from the time we started this experiment. The digestion is almost over. It has attained 420 degrees Celsius. It has maintained at 420 degrees Celsius. Now, the importance of the temperature, please refer the Kjeldahl guide. It is not that we have to do digestion at 420 degrees Celsius for all the samples. For each particular sample, there is a particular temperature, but most of the digestions happen at 90% of the digestions happen at 420 degrees Celsius. Now, since we have given quartz tubes, there is no need of ramp and soak. Okay. Now, what do you mean by ramp and soak? That means in some of the instruments, they attain temperature from ambient to 100 degrees Celsius, and later on from 100 to 200, 200 to 300, and then from 300 to 420 degrees Celsius. This is required only if you are giving borosilicate tubes, because borosilicate tubes cannot be suddenly heated or cooled. When you give quartz tubes, you can increase the temperature from ambient to 420 degrees Celsius in one single step. You don't have to ramp, soak. You can go from ambient to 420 degrees Celsius in one step. Now, in certain material which are very amorphous, there might be frothing, or during digestion the sample might jump or rigorously jump inside the digestion tubes. For such samples, we recommend you to use glass rods or glass beads or anti-foaming agents. This will prevent frothing or foaming or jumping of liquid, which will result in inaccurate digestions. Now we have taken all these samples, and how do we confirm whether this procedure is correct? Now, to confirm whether this procedure is correct, you can use a standard sample. Usually, glycine, which is 99.9% pure, is used as a standard sample, or acetanilide is used as a standard sample. What do you mean by that? It means that suppose if you take 1 gram of glycine, the nitrogen content is 18.6%. So, to confirm whether the procedure what I am doing is correct, initially or at a later stage, you can take 1 gram of glycine in all the digestion tube and conduct the same experiment, do the distillation, and confirm whether you are getting 18.6% nitrogen. If you get 18.6% nitrogen, it means that whatever digestion you have done is perfect. The same thing applies even to acetanilide. Acetanilide has a standard nitrogen content of 10.6%. So, instead of taking your sample, you can take 0.5 or 1 gram of acetanilide and confirm the digestion process is correct. Now, I shall just lift it and show it to you. as you can see, the liquid has become clear, which means that the digestion cycle is over. I shall just hand it here. Okay, and switch off the system. From the digestion experiment, you can clearly see that all the liquid has become clear. It is bluish green in color. The color is because of the catalyst used. Okay. Now this ensures that the digestion is 100% perfect. There is no carbonized material here. Allow it to cool for certain amount of time and then start the distillation process. Now, if a customer wants to do multiple experiments, what he can do is, he can buy one more set of spare digestion tubes and one more holder. So, when he finishes up with the first one, he can load the second one and continue the second experiment. Okay? This is only for people who want to do multiple digestions. But most of the people do 6 or 8, so this is more than enough. Thank you. Now, once the digestion is over, you have to go to the next step, that is the distillation. Now, as you can see here, we have completed the digestion. After digestion, it is preferably required to dilute it with distilled water and keep it to avoid crystallization. You can observe small amount of catalyst here. So, to avoid this solution to crystallize, it is always preferred to add around 10 to 15 ml of distilled water and store it in 50 ml of conical flask. Okay. Once you do that, you can do the experiment or the distillation next day also. Now, this is the Kjeldahl distillation unit. Let me identify the parts. This is the boiler or the steam generator, which is used to generate the steam. This is the additional funnel which is used to top up the water required for distillation. This is the outer jacket which is used to collect the spent liquid. There is an inner tube which holds the digested sample, inner tube, with a bubbler, and then we have a sodium hydroxide additional funnel, a splash head or a Kjeldahl trap, a condenser, and finally conical flask. Now, after installing this unit, we need to take standard solutions. First we have to take boric acid, then we require sodium hydroxide, alkali, and then a mixed indicator which we have to add it to boric acid. Now this indicator is used for color determination to show the transition of the solution from acidic to basic medium. Now after you prepare all these standard solutions, you have to take the conical flask and add around 25 ml of boric acid solution. Now I have taken the conical flask. I will add 25 ml of boric acid solution. Now, before starting your experiment, please rinse all the glassware with distilled water, dry it in an oven so that there is no impurity being added from other components. So, you please rinse it with distilled water and then dry it in an oven. So, I have taken boric acid here. This contains boric acid, and then I will add mixed indicator. Shake the indicator thoroughly, okay. So this is boric acid solution with mixed indicator. I will keep it here. Keep it in such a fashion that the silicon tubing get immersed in boric acid solution. Now this is very important. Why? Because when ammonia is being generated, we have to capture the entire ammonia in boric acid solution. So hence the silicon tubing should be completely immersed in boric acid, so that when ammonia is absorbed in boric acid, it becomes ammonium borate and there is a change in color. So this is very important. You have to immerse it in boric acid solution completely. This is unacceptable. Okay. Hence, only this position is acceptable. It should be immersed. Now, this is the digested solution. I will add some amount of distilled water. Okay. Pause. Start. Okay. Now, I shall take the digested sample and add it to the dropping funnel carefully. Okay, I have added this. Now I shall add some amount of distilled water and rinse it and remove the remaining digested sample. Around 30 ml of distilled water. Now I shall open the stopcock. I shall add some more amount of distilled water to remove the entire I have added some more amount of distilled water. Okay. Now I shall close the stopcock. Now I shall take sodium hydroxide solution. This is around 40% sodium hydroxide solution, which is 400 grams of sodium hydroxide dissolved in 1 liter of distilled water. I am taking approximately 40 to 50 ml. I shall take 50 ml and add only 40 ml. I will see if the entire acid gets neutralized. Okay. Now I have added 40% sodium hydroxide solution. Now, please observe this step, which is very important. Before starting the distillation unit, I shall release the stopcock to ensure that there is no vacuum which is generated in the outer vessel. Okay, so I have released the stopcock to ensure that there is no vacuum, and initially the steam will start bubbling. Okay, I'll switch on the unit. It will take around 5 minutes for water to get heated up. This is only during the initial stage. Later on, the water would have already got heated up and the experiment will happen very quickly. I have started the heater. Now I shall start the cooling water flow in the condenser. You can observe there is cooling water flow in the condenser. Okay. Now, after digestion, I shall transfer the liquid to this distillation unit. The distillation unit mainly consists of boiler, condenser. I have kept boric acid solution with mixed indicator here. The outer jacket which is used to take the spent liquid, and then there is an inner jacket where I am going to load the digested sample. Now before loading, I shall just open this valve, okay, and then load it. Transfer the entire digested sample. Do not leave even a drop of it. Okay. I am going to open the stopcock and allow the liquid. I shall switch on the heater. I have opened the pinch cock. This is required to remove the steam. Now I shall close the pinch cock. I shall take sodium hydroxide solution. Around 40 ml of sodium hydroxide solution is required. I shall take approximately 50 ml. I shall retain 10 ml. Now, I shall open the cooling water circulation. And then release sodium hydroxide. I have opened sodium hydroxide 40%. You can see, observe the reaction. After few seconds it will become dark brown, which ensure that there is total neutralization of acid alkali. This is very important. It has to become dark brown. collect approximately 150 ml of the solution. You can see here it has changed from pink to green. So once I have collected around 150 ml of the solution, I shall remove the conical flask and then switch off the heater. Now once I switch off the heater, the entire spent liquid gets sucked into the outer jacket due to vacuum. This you remove it, rinse it with plenty of distilled water and start the next experiment. You can observe it now. Please observe it. The liquid will get siphoned into the outer jacket.
This one, you will here. Okay, you have to remove from
Yes, from there you have to remove. Rinse it with distilled water.
But how the walls of that inner tube will be get clean?
This one?
Inner tube, inner jacket.
This inner.
The reaction where
Now, as you can see, the water has started boiling in the boiler. Okay, at this point, I shall close the stopcock. Now, the steam will go from the boiler inside this jacket, and it is boiling the digested sample. Okay. Now once the boiling starts, now I shall add sodium hydroxide solution. As you can see, the color of the digested sample has become dark. I shall close the pinch cork, and you can observe it here. The solution has already turned green. Okay, you can observe it here. The solution has already turned green. Ammonia has absorbed in boric acid solution, and it has become ammonium borate. Collect approximately 150 ml of the solution so that you are 100% sure that all ammonia has been captured in boric acid solution. So you have to capture around 150 ml of solution. So you need to capture 150 ml of the solution. So after I have captured 150 ml of the solution, I shall just move the conical flask and then rinse the silicone tubing. Okay. I have removed this. Now I shall switch off the unit. Please remove the conical flask and then switch off this unit. Now once I switch off the unit, all the spent liquid is being siphoned into the outer jacket, which can be removed later on by opening this pinch cork. Okay. I shall just show it to you. I shall rinse it with some amount of distilled water. I shall remove the spent liquid by opening this pinch cork. Okay. Be very careful. Use gloves. I shall apply the pinch cork once again. You can rinse it one more time if you desire. So as you can see from the center tube, all the liquid has been rinsed and the entire liquid has been removed. So you can start the next experiment. Now, after distillation, you can see here this is ammonium borate solution with a pH greater than 7. This I shall titrate it with 0.1 normal HCl. This is the correct method of doing the titration. Okay. Note down the value of HCl. I have used 0.1 normal HCl. Okay. Note down the burette reading and go for the calculation. Now, for most of the samples, after finding out the percentage of nitrogen, you have to multiply by a factor called 6.25 or 6.38. Okay, 6.25 or 6.38 depending upon the food articles or dairy product. Okay, thank you.
Again, 6 after